Welcome to Lavanya's computer classes. In this video, I will explain introduction of Dbms. What is Dbms? What are the related terms are used in Dbms? I will explain in this video. So in this Dbms, what is the full form of Dbms? Dbms means database management systems. Database management system. So that is the full form of Dbms. D for data, B for base, database management system. So in this full form, first I will explain what is data. Next, what is database. So what is data? What is data means any raw fact is known as data. Any raw fact is known as data. What is the meaning of raw fact? So what is the meaning of raw fact? Raw fact means anything, if you are typing using keyboard, if you are typing anything, that is called as raw fact. For example, 1, it is a data. A is a data. Any value you are typing through keyboard, that is called as data. For example, x or 89.2. So these everything is called as data. Any raw fact, whatever the data you are using through keyboard, you are typing through keyboard, that is called as data. So next one is information. This is also one more word. So what is the information? What is information means processed data. Processed data or data with meaning is known as information. So second word is what is information. What is information means processed data or data with meaning is called as information. So here 1 is a data. What is 1 here? What indicates? 1 is your roll number or 1 is your age or what is the 1? 1 is your marks, whatever it is. 1 means data is not telling anything about what is the purpose of that. But information means, for example, I write like this, serial number equal to 1. Then what we are understanding? 1 is the value, that means data. It represents now serial number. Or otherwise you just write like this, A is equals to 1. That means any small kid is there. What is the age of that small kid mean? That is the 1. So here 1, just one value, 1 is known as data. But what is the purpose of 1? 1 indicates either serial number or age that have some meaning is there. That is called as processed data. That is called as information. Here A, what is A? A is a grade or A is a section. What is it is means? If we specify this is the section of one class, section A, that is called as information. Triple X, what is the triple X? Any soap name or any name or pass, whatever it is. So anything processed data, data with meaning is known as information. Now we go for database. What is the meaning of database? Database means collection of data. Collection of data after collecting all the data, related data. After collecting all the related data stored in one place, that is called as database. Collection of data, collection of related data is called as database. Database is stored in the form of tables also. Tables. For example, I want to collect student database. Student database means information. Collection of students' information stored it in a table format, that is called a student database. So what are the student database? What type of information is there? Like serial number is there for any student, student name, some age, some marks. So I want to collect the information about student. Information means processed data. Processed data of student, that is called as student database. Serial number 1, student name is A is 18, some marks he is getting out of 25, he gets some 22. Next, second student number 2. What is the name of the second student means like B, what is his age? 17, how much marks he got? It means some 20. The third student C, some again 18, some 21. So like this, if you are collecting the information about any students, collection of information, collection of data or collection of information is called as database. So this is the example for student database. In this student database, now I will explain some words. These are there. So how many students information is stored in this example? It means 3 students information are stored. Student number 1 information, second student information, third student information. So these horizontal lines are called as rows. So these are the horizontal lines. These horizontal lines are called as rows. The rows are called as records. The rows are called as records. Records. These vertical lines, what are the vertical lines? These are the vertical lines, marks, age, student name, serial number. The vertical lines are called as columns. Vertical lines are called as columns. These columns are called as fields. First of all, database is stored in the form of a table. Table, what is the meaning of table? Table means, any table means it contains rows and columns. Table is the combination of rows and columns. In our database, rows is called as records and columns are called as fields. So in this example, what are the fields means? The fields are serial number is one field, S name is another field, S name is student name. Age is a field and marks is also a field. The combination of all the fields is known as record. The combination of fields is known as record. So in these words, what are the terms are used means, what is data? Data is the, any raw fact is known as a data. Next, database. What is database? Collection of data, processed data. Collection of all the data stored in one place is called as database. What is information? Information means data with meaning is known as information. What is row? Row means data is stored in the form of a table. In the table, the horizontal line is known as row. Row is also called as record. Then column. Column means vertical lines. These are the columns. Serial number is the one column. S name is one column. Column the smallest individual unit in the table is also known as a field. 1 is a field. Serial number field, its value is 1. So rows of the, for example, field. Field is the individual element. Individual element is the field. Combination of fields. Combination of fields is known as record. Collection of records. Collection of records is known as a table. Table or file. So this is the student table or student file. In this, how many records are there? There are 3 records are there. How many fields are there? There are 4 fields are there. So this is a small introduction about database management system. In this, after that I will explain some more what is the management DBMS full form. So now we are explaining traditional file system, because before using DBMS we have file systems are there. So what is a file system? Means file system is allows to access a single table or single file at a time. File system is also used for storing the data. Everything is in the form of files, but in the accessing time it is possible to access only one table at a time. And there is like this, so many files are maintained, so many tables, so many files. But the files have no relation one to another. There is no relation one file to another file. That's why there is no sharing, because each and every file maintains its own information. Each and every file has its own tables. So there is no relation one to another. There is no relation means there is no sharing also. So whatever the problems are faced in the file system, for recovering that problems, for removing that problems, we are introduced a new system that is called as DBMS. So what is the full form of DBMS? Means database management system. So in the database management system, already we know what is data and what is database. Now what is the database management system? What is database management? We have to managing some database. So it is first of all, DBMS is an application software. DBMS is an application software that allows users to define, creating your database, create and maintain and sharing your databases and sharing the databases. So DBMS means DBMS management means how we are managing your database. Database means collection of information. So how can you collect? After collecting, how can you create where you want to store? Or after storing the data, if you want to insert any new information, or if you want to delete any already existing database, or if you want to change any modifications, that means in the maintain what we have to means insertions are possible, deletions or updations. These all are known as maintaining and sharing also. For example, in the previous example, I gave one example like student database. In the student database, how many records are there? 3 records are there. After storing, this is the creation. After creating, after some time, for example, I know the marks of the student is increased, some correct counting mistake, something. So now 21 is changed to some 24. So I want to change the marks in already existing database. So that is possible in database management system. This is called as maintenance. Once database is created, you are storing entire database in the database. If you want to delete or insert or modification, this is called as modification. Our second student wants to take the TC from our college. So I don't want to the second student information. I want to remove the total second student information. So how it is possible? That is also possible using some deletion operation. So insertions, deletions or updations are possible in the DBMS. That is called as maintaining the database. Not only just creating and storing. Once our creation is over, how can you maintain? And then sharing also. The information is sharing to others. That is also possible in DBMS. So in the defining database, in the creation means defining the database. In the defining database, how we are defining, what it involves. Involve means it involves data types. In the defining term, we have to specify what is the data types of data, what is the structure of the table, and also what are the constraints of this database. Everything is known as defining the database. Data types. What is the data types means? Again, we just check it in the previous. This is example of database in this serial number. In the serial number, what type of values are entered? 1, 2, 3 numerical type. In the serial number, we are not write like any information like A. A is a wrong valid data. So how can you, so in this particular field, which type of data you have to enter, that is also specified at the time of defining database only. That is called as data types. What type of data types we require? Structure of the database. How many fields we require? What is their data types? Any constraints. For example, student age, marks. This is marks, I already said this is marks for 25. If any student by mistake, if you are typing the data some 30 instead of 20, I put 30. If you are accepting the, if you are enter the data, type it like this, is in the entry time only compulsory, refusing, it is not proper data. Because total marks is only for 25. How will the student get 30 marks? So if you are typing any, like typing mistakes, at the time of entry only have to tell that one it is not a proper data. Some data is missing. Something is exceeds our range. So this is called as constraints. These constraints is also possible in defining the databases only. So this is the definitions of DBMS. So in this video, we'll just explain what is DBMS, what are the proper terms used in the DBMS, and what is file system and what is DBMS. File system means it is a DBMS, but it is used for storing only single files. There is no relation and no sharing. In next video, we'll explain what is the advantages of DBMS compared to file systems. In this video, I will explain advantages of DBMS. In the previous video, already explained what is DBMS, what are the terms used in the DBMS. So what is DBMS means? It is an application software, allows to users to define, create, maintain and sharing database. So what is the DBMS means? It is used to, gives the permission to, allows the users to defining and creating the database, maintaining the database and sharing the database to the users. So in this, before DBMS, we have file processing systems. traditional file processing systems. In the file processing system, each and everyone, it is allowed to access only single file and there is no relation to other files. So now we will go for what are the advantages of DBMS. So what are the advantages of DBMS, and these are the disadvantages of file processing system also. So what are the advantages of DBMS means? First advantage is, I will explain, first I will do the list, after that I will explain each one. So first one is data redundancy. Data redundancy and inconsistency. Data redundancy and inconsistency, removing data redundancy and inconsistency. Next, improving data sharing. Improving data sharing. Next, data concurrency. Data concurrency. Fourth one is data searching. Data searching. Fifth one is it maintains data integrity. It maintains data integrity. Sixth one is data security, improving the data security in DBMS. And seventh one is data crashing. So these are the reducing the data crashing. So these all are the advantages of DBMS. So what is first one means data redundancy and inconsistency. Data redundancy. What is the meaning of data redundancy? Means repeating the data. It reducing. In DBMS, it reducing the data redundancy, but in file processing systems, data is repeated number of times. Because in the file system, each and everyone maintains its own files. And each file contains only one table at a time. So number of peoples are maintain their own systems because there is no sharing. One file is not related to another file. There is no sharing. So that's why each and every file maintains its own data. Whenever the files are maintain its own data, data is repeated. Whenever the data is repeated, number of copies are more. That is called as data redundancy. Whenever the data is more, data is available in number of places. In one place, if you are do any changes, the changes are reflected in one file, but it is not reflected in another file. So that's because of that the data is in consistency problem. Maintaining the consistency. Consistency is missing. That is called as inconsistency. For example, there is one file, another file. Both the files are maintaining the student information only. For example, here two students information is there. Serial number 1, serial number 2. First one is stored in POT, second one is in habits, address. Similarly, here also same thing. Same information is available in number of places. That's why that is called as repetition, data redundancy. It is there in the file processing system. So one student, if first student come and change his address. My address is changed, ma'am, that is from Koti to somewhere, some Dilshuk Nagar. So that changes is applied in the first file but is not applied in the second file. So according to first file, what is the address of the first student mean? That is Dilshuk Nagar. But in the second table, what is the address of the first student mean? That is Koti. That means data is mismatched. Data is not in consistency form. So these are the problems are available containing in traditional file system. Why means because in the traditional file system data is repeated number of places. Same data is stored in different places. If any time any modifications are applied, that is applied in one place and not applicable in another place. So data is not in the consistency problem. So these all are reduced in DBMS because in the DBMS data is not repeated. So reducing data redundancy. Because of reducing the data redundancy, data is in consistency form, not in inconsistency. Entire data is in the consistency form. So this is the first advantage of data DBMS. Second one is data sharing. In the definition I said what is file system is In this, each and every file maintains its own information. There is no relation to other files. That means only one table is stored in one file. There is no sharing. But DBMS is not like this. It is a centralized database. All information is stored in one place, and all users are use the same database. That's why it is called as data sharing is improving, because data is not repeated number of times. All the data is stored in one place. That's why it is called as database. So more number of users are use the same database. That's why automatically sharing is increased. So that is also one advantage of DBMS. Next one is data concurrency. What is data concurrency? Concurrency means number of users are used same data at a time. Whenever number of users are used same data at a time, some problems are occurs. That's problems are called as anomalies. So these are the same thing. Same information is number of users are used the same database. One student is changed the address and another student is not able to take that error. So that's why automatically errors are occurred. That those errors are called as either insertion anomaly, deletion error, or updation error. Because database means maintenance. Whenever you do all these applications, either insertion, deletion, updation, some problems are occurred because number of users have used the same database. So for reducing these anomalies, we have some software is there that is called as for locking system is there. How can you controlling at a time? Don't use number of users at a time. So in DBMS we have lock system is there. Using the lock we have to maintain concurrency. So these are all there. It is known as concurrency techniques. So these are available in DBMS but not in file processing systems. So that is also one advantage of data concurrency. Using lock system, you can lock the database. It is not opened by the others. Once one user is over, working is over, then go for second user. So like that we can maintain the concurrency controlling techniques. Next one is data searching. Data searching, why you are storing, what is database means? Collection of information stored in one place. For what purpose you are storing the data? For any future reference, if you want to use or if you want to search any database, that is called as data searching. But in the file processing system, you have to write some different application program for searching the data. But that means it takes some time. That is one disadvantage. But in DBMS, inbuilt functions are developed using small queries. Just write small queries. Using that queries, it is possible to search the information. Very quickly we get the information compared to file systems. So that is also one advantage of DBMS. Next one is data integrity. Data integrity means we have to maintain all the data in the integrity format or not. So integrity format means we have to maintain some constraints. Using these constraints, we can maintain the data integrity. For example, you have two files are there. This is the employee table and second one is the department table. So what is department table means? How many departments are available in your organization. For example, in our organization, only two departments are there. Department number 10, department number 20. Now what is employee table? Employee table means it contains all the employees information. Employee number and that particular employee number working in each department. For example, employee number 1 is working in department number 10. Employee 2 working in 20. No problem. If we write employee 3 is working in 30, it is accepted the data because data type of department number is number. So 30 is also a number, it accepted. But it is a proper data because 30 is available in your organization, in your company. Any department like 30 department is there? No. That means you have your organization. We have only two departments. So any number of employees are working in your organization, but all are working must be in 10 and 20 only. So before entering the information, you have to check it is a proper data or not. 10 Before entering the department number 10, we have to check the department is existed or not. Yes, it is existed. 20, it is also existed. But before entering 30, department number 30, before recruiting any employee like 3 is working in 30 minutes, you can identify it is not a proper information. Something is mistake here because 30 is not available in this. If you are without checking anything, if you are maintain the database like this, then we say data is not in the integrity format. So for checking, before only have to check these conditions. So these are all are called as constraints. So maintain the, using constraints, we can maintain the integrity of the data. That is also possible in your DBMS. Next one is data security. In file processing system is also data security is there. Is improving data security in DBMS. So how can you secure your data in olden days? Means we are using password system. Password is there, but using only simple password, anyone can hack that password. It is also a protecting the system, but not up to the mark. So how can you improve your protection of your database? Means in the DBMS, so many techniques are there. So using the techniques, you have to increase your security methods. So improving data security. And last one is data crashing. So whenever any problem is available, either virus problems, whatever it is, system will be crash. If the system is crash, entire data is lost. It is recovery is very difficult to take in file processing system. But in DBMS, we have so many recovery methods are there. Recovery techniques are available. Using the recovery techniques, easily we can get it back to the information. So these all are the advantages of DBMS. Data redundancy is reduced. Because of redundancy is reduced, automatically all the data in the consistency form. Data sharing is improved. Data concurrency, we have to maintain data concurrency using logging systems. Data searching is very easy and very quickly we can search the data in DBMS because we have only small queries are there. Inbuilt functions are there. Using inbuilt functions, we can easily search the data, and we have to maintain data integrity rules. Integrity constraints are there. Entity integrity, referential integrity. Those all are explained in the next videos. So maintain those constraints. The data, every time the data is in the integrity format. Next, the data security is improved compared to file processing system. Next, because so many password techniques, not only password techniques, so many techniques we have. Using those techniques, we have to improve your security measurements and data crashing. If any time if a data is lost because of any problems, either incidental accidents or unavoidable accidents, if anything is happened, immediately it is possible to get it back to the information. So that is using recovery techniques, we can easily recover your database. So these all are the advantages of DBMS, and these are also disadvantages of file processing system. Data redundancy is more, no data sharing, concurrency problems are more, searching takes difficult, more time, it is not maintained that much integrity, data security is less, and data crashing is, if any data crashing is there, more loss will be available. So these all are the disadvantages of file processing system and advantages of DBMS. Video I will explain ER model. ER model is the one best example for data model. So what is data model means? Data model means modeling data, that is to give a shape or structure to the database. So what is data model means? Data model is a model that is used for representing. It gives some information about shape or structure of the database, how the database looks like. What is the structure of the database? This is everything is explained in the data model. The data model makes it easier to understand the meaning of the data by its structure. If we just see the structure of the database, then immediately we can understand what type of data and what is the structure, what are the fields are available, everything is in the database. So that is explained by the data model. In the data model, so many models are there, but now I'll explain one best, most widely used data model is ER model. So what is ER model? ER. The ER model is known as Entity Relationship Model. E means entity, R means relationship model. ER model means entity relationship model. It is the most widely used data model. So whenever we are designing any database, we are using ER model. It is also referred as high level conceptual data model. High level conceptual data model. The main purpose of developing ER model is to support the user's view about the data and to hide the implementation details associated with database design. In ER model, E means entity and R means relationship. So in this video, just explain what are the components of ER diagrams only. So what is E and what is R? R means relationship and E means entity. These two are the diagrammatic representation of entire database design. So the diagrammatic representation of any ER model, that is called as ER relationship diagram. So it is the diagrammatic representation of logical structure of the database. Logical structure of the database. It is a diagrammatic representation. That's why we need some symbols. Graphical representation we need. So data model means so many data models are there. In this one model is ER model. E means entity, R means relationship diagram. So it is explains only logical structure of the database with entities and relationships. But it does not explain anything how it will be implemented. Implementation details is hide. So now we'll go for basic components of ER diagrams, ER model. Basic components means here mostly the three basic components are there. One is entities. Second one is attributes. Third one is relationship. Entities, attributes, relationship. These three are called as basic components of ER diagrams. So E for entity means E, relationship means R. That's what is called as ER diagram. Now we'll explain first component of ER diagram, that is entity. So what is entity means? An entity is a real world object. An entity is a real world object. Real world object that is distinguishable from other objects. It is distinguishable from other objects. So everything is known as an entity. Real world object. In the real world object, apple, mango, student, employee, person, everything is known as entity. So in ER diagram, already we explained ER diagram means in the ER diagram it's a diagrammatic representation. So in the diagrammatic representation, everything is in the form of a diagram. So it is represented by a symbol. So what is the symbol used for representing entity means that is a rectangle. So rectangle is a symbol. It is used for representing an entity. So what is entity means? Entity is a real world object. In ER diagram, rectangle shape is used for representing the entity. For example, student. Student is an entity. It is a real world object. So how can you write the student in the entity diagram? So student is an entity means we just represent like this. Inside that rectangle box, we just write the name of the entity set. Person. Person means person is the name of the entity. How can you represent means inside the rectangle box, we just write like this. So this is the representation of an entity. Now we go for entity set. So what is an entity set means? Collection or set of entities is known as entity set. Collection of all entities is known as entity set. So this is also entity set because it is a collection of entities. Collection of entity means one real world object. So if we are collecting so many objects, one student is called as one entity. Collection of all students is called as entity set. So this is the representation of entity set. Okay. Now we'll go for next component is attribute. What is the attribute? What is attribute? Means uniquely recognizable. So what is attribute? Means a single value in the entity is known as attribute. Single value in the entity is known as attribute. Unique value, individual value is known as attribute. The unique value of an attribute is known as key also. The attribute, in the attribute, which one is unique values, which attribute contains unique values, that attribute is also known as key. So in ER diagram, which symbol is used for representing a attribute? Means that is ellipse. Ellipse is used for representing attribute. So rectangle is for entity set, ellipse is for attribute. For example, student. Already the previous videos I explained student table. How a student table is there? Means like this. It is the student table. The student table contains the fields like the serial number, student name, age and marks. Already in the previous videos I already explained. This is the table structure, database structure. Table means collection of rows and columns. So these all are known as fields. These all are known as fields, and horizontal lines. These horizontal lines are called as rows or records. Already in the previous video I already put this database concept. So in this field, individual value is called as field. Field is nothing but an attribute in ER diagram. Similarly, row. Row means record. One row is called as a record. The record is nothing but an entity, single entity. Table, student table. Table is nothing but an entity set. So this is the relational data model. In the relational data model, we are using these words, and this is the ER model. Data models are different, but concept is same, but terminology is different. In the relational model, we are field, record, table. Field means individual value, record means one row, table means collection of records. In ER model, attribute, entity, entity set. Entity set is nothing but a table, entity is known as record, attribute is known as field. So attribute is representing this one. Next one is relationship. Relationship. So what is the relationship? Means relationship is known as the association. Association or relationship between two entities. Entity sets, between two entity sets or between any two entities, whatever the relationship, what is the association between two entity sets is called as a relationship. A collection of similar relationship is known as a relationship set. Is known as a relationship set. So these are the some proper words we are used in the ER diagram. Entity, entity set. Entity, entity set. Attribute, relationship, relationship sets. Okay. So what is ER model means? ER model is a data model, diagrammatic representation of logical structure of the database. What are the components of ER diagram means? Entity, entity set, attribute, relationship, relationship set. And diagrammatic representation, rectangle is used for entity set. This one, ellipse is used for attribute, and relationship, for relationship we are using rhombus. This is used for relationship diagram. These are the basic components. Going to explain types of entity sets. In the ER model, already I explained in the previous video, I explained components of ER model. In the components of ER model, entity and relationships are there. Now I will go for what are the different types of entity sets. So what is an entity? Means entity is a real world object. So any real world object is known as an entity. Collection of entities are known as entity sets. Now we go for what are the different types of entity sets. So now we have two types of entity sets are there. One is strong entity set. Strong entity set. And the second one is weak entity set. So these are the two types of entity sets. So what is entity means? Entity is a real world object. What is entity set means? Collection of all entities is known as entity set. Which symbol is used for representing entity set means already we know that is rectangle. Rectangle box is used for representing entity set. So how many types of entity sets we have means we have two types of entity sets are there. Those are, one is the strong entity set, second one is the weak entity set. Now we go for what is the strong entity set. Strong. So in the name only it is the strong entity set. How you know it is a strong entity set means any entity set can be uniquely identified using its primary key attribute is known as a strong entity set. Any entity set is uniquely identified by using some attribute that is called as primary key, that is called a strong entity set. Or simply any entity set have primary key, that is also called as strong entity set. Any attribute, any entity set has primary key, that is called as strong entity set. So what is the use of primary key means? Primary key or entity set uniquely identification means it is used for identifying the entity set. For example, I will explain. This is the student table, student entity set. Entity set means collection of entities. For example, like this: serial number, student name, age. If you take like this. So these are the fields, attributes of an entity set. So how can you represent this means? We can represent like this. Student is the entity set name. We are using like this, entity set. So here we know, how can you know it is a strong entity or weak entity means first we take some value. Serial number 1, student name is A, age is 18. Again we take another second record. The student name again A, no problem. In the class, two students' names are same. It is possible. Two student names are Rama, two students' names are Deepa, Krishna, whatever it is. A is also, because all are the same class, so almost all A's will be also same. So both the students' names are same and age is also same. But how can you identify one student to another student means we need one attribute should be different, unique, like your roll number or your hall ticket number, because hall ticket numbers are not common for student to student. Hall ticket number should be different from student to student. So like this. So here 1 is the roll number, 2 is the second student roll number, hall ticket number. So if you are called, any student called by name A means both the students are raise their hand because both the names are same. Similarly, according to age also are not possible to identify. But how can you identify one student to another student? How can you differentiate one student to another student? Means we need at least one field should be different from other fields. So which field is different, uniquely taking the values from other values, that is through primary key it is possible. I will explain what is the primary key concept in the next videos. So which attribute has primary key or through which attribute it is possible to identify that type of entity set is known as strong entity set. So any entity set have primary key, that entity set is called as strong entity set. So this is the example of strong entity set because here serial number or all ticket number, whatever it is a primary key attribute. So the primary key attributes are represented by underline. If any field down underline is there means it is a primary key attribute. If an entity set has primary key, that is called as a strong entity set. Strong entity set is represented like normal rectangle symbol only. So this is the definition of a strong entity set. So what is strong entity set means? Any entity set with primary key is known as a strong entity set. Next, second category. What is the second category? Weak entity set. In the name only it is there, it is a weak. That means it is not possible to identify any record uniquely, or otherwise any entity set has no primary key attribute. Has no primary key attribute. It is called as a weak entity set. If it is a primary key, for example, I will give one more serious student's roll number is also 1, means immediately it is not accepted. Because serial number is primary key, means it not accepted duplicate values, because 1 is already repeated. It is not accepted duplicate values. That is the concept of primary key. So any as entity set has primary key, that is called as a strong entity set. Weak entity set means has no primary key. For example, here are taking employee number, employee name, company name, where he is working. So this is the table or entity set, whatever it is. So in this, employees names, 2 employees companies are there. Company name A, or otherwise go for HCL, go for ECIL. One more employee is also HCL. Employee name A, another employee name is also A, another employee name is B. So here employee name is A and employee name is also A, and here AB, here also AB. HCL, here also AB. But employee number should be unique. But if you are not mentioned, it is a primary key. There is no primary key concept, you are not introduced, means employee number is also like a normal key. Whatever the values are entered, it is accepted. So here 1 AB HCL, 1 AB HCL, because you are not specify the primary key. Any attribute has no primary key. Primary key is not there, means that accepting duplicate values, repeated values. Here first row and third row, both the rows are same. There are 2 employees are there, both the employees names are AB and both are working in HCL. So that means these 2 things are possible to common values, but compulsory we take employee number is different. But you are not mentioned any primary key concept here. If you are entered employee number 1 is twice, mean that is also is accepted. So how can you recognize, how can you differentiate these 2 employments? There is no separate field is there. So there is not, in this example, it is not possible to identify one person to another person. So any entity set has no primary key, or any entity set is not possible to identify uniquely. Not possible to identify uniquely. That is called as weak entity set. So how can you represent weak entity set? Means rectangle only, but 2 rectangles. 2 rectangle symbols. 2 rectangle symbols are representation of strong weak entity set. I will give the example. One is for strong entity, another one is weak entity. This is the strong entity set. For strong entity sets, only 1 rectangle. In this, student with serial number. This is the attribute. I will explain the next one. Attribute and S name, some A's. So in this, which field, which attribute is possible to identify? That means it's possible. Which attribute is possible to uniquely identify, means that is serial number. So we write underline of serial number. So any attribute has primary key. It is known as a strong entity set. This is a strong entity set representation. In this, serial number is a primary key attribute. So through this one we can easily identify. Weak entity set. Weak entity set means there is no primary key concept. Double rectangle. So inside the double rectangle we use employee table. Employee table has employee number, employee name, organization name. O name means organization name. Here we are not keep any underline. That means we are not keep any primary key. No primary key concept in this example. So no primary key means it is not possible to uniquely identify. So this is the example for weak entity set. So these are the what is entity sets, types of entity sets. Already we know what is an attribute. Now I will explain what is the types of attributes also. So what is an attribute means a single value, individual value in the entity set. or in the entity is known as an attribute. Single value in the entity is known as an attribute. For example, student entity. Student entity means what are the values are taken in the student means we have serial number, student name, age, like this. So serial number, student name, age, all are known as attributes of this entity student. Attribute means single value. Serial number is a single value. So in ER diagrams, ellipse is used for representing an attribute. So ellipse is the symbol, it is used for representing an attribute. Now we'll go for what are the different types of attributes are available in ER model. So what are the different types of attributes means first one is simple or single valued attribute. Either simple attribute or single valued attribute. Second one is composite attribute. These are the different types of attributes. First one is simple or single valued attribute. Second one is composite attribute. Third one is multi-valued attribute. Single valued opposite is multi-valued attribute. Fourth one is derived attribute. So these are all are the types of attributes: single valued or simple valued, composite, multi-valued, derived attribute. Now we'll explain each and everything. Now we'll go for what is the single valued or simple valued. Single valued means the name only it is there, it takes only single value at a time. Or simple value means the attribute is not possible to divide it into subparts. For example, here I take a student entity set with some attributes like serial number, student name, age, marks, address. So these are the some attributes of the table entity set student. Collection of entities is known as entity set. So skills also. So serial number, S name, age, marks, address, skills are known as attributes. So if the serial number is in this all the attributes, serial number is the simple or single valued attribute because it is not possible to broken into subparts or it takes only one value at a time. For serial numbers, how many values are given? Only one. So which symbol is used for representing single valued means for like normal attribute, that is ellipse only. Now I will explain one more attribute, that is composite attribute. So what is the meaning of composite attribute? Composite attribute means it is an attribute, it is possible to divided into subparts. So what is composite attribute means it is possible to divided into subparts which can be broken down into so many parts. So that is called as composite attribute which can be divided into subparts. For example, S name. In the previous example for student, I took one variable attribute like S name. So what is the meaning of S name? It's student name. Student name contains, it is possible to divide it into first name, middle name and last name. So first name means so like initial name, middle name means your original name, last name means any other part. If you are taking address, address is also an example of composite attribute because it is also possible to divide it into so many parts like door number, street, city, state, pin code, your wish. So address is also divided into so many parts. So any attribute is possible to divide it into many parts, subparts is known as composite attribute. So which symbol is used for representing composite attribute? This is the symbol. Simple attribute, and how many parts is possible to divide it? That number of ellipses you put above that attribute. For example, I will show you how to draw a S-name composite attribute. S-name is put it in the attributes simple ellipse. Then what are the parts? Those everything keep it in the above that ellipse. First name, middle name and last name. So this is the example for composite attribute. Similarly, I draw address also. So address is an attribute. Keep it in the ellipse. But it is not a simple one. It is a composite attribute. So what are the parts? Door number is one part. Street is another part. City is another part. So all parts are keep it above that attribute. So this is called as composite attribute. Any attribute is possible to divide it into subparts. Now we'll go for. So in this single attribute means it is not possible to divide it into subparts, or it takes only single value. So now I'll go for one more attribute, that is derived attribute. Derived attribute. Derived, in the name it is that it is not a original one. It is coming from some another attribute. Its value is derived from another attribute. That's why it is called as derived attribute. Its value is obtained from another attribute. For example, age. How can you calculate the age of a student or age of a person? Means first if you know date of birth and present date, then only we know the age of a person. When his date of birth and what is the today's date. Today's date minus date of birth. Then we automatically get your age. So age, if you want to calculate age means we need some other values also. Present date and date of birth. Then only we get the age. So age is known as a derived attribute. Like total. How can you calculate total marks of the student means? We can get marks in subjects, marks in first subject plus marks in second subject plus marks in third subject. Then we get total marks. So total is a derived attribute. Similarly, average. How to calculate average means total marks by number of subjects. So without knowing total marks and number of subjects, it is not possible to derive the value of total average. So which symbol is used for representing derived attribute means dotted ellipse. So now representing age. Age is a derived attribute. So we just put total is a derived attribute. So dotted ellipse. In the dotted ellipse we just write TOT. And similarly average. Average is also a derived attribute. And age is also a derived attribute. So we just represent like this. Age. So derived attributes means its values are coming from some other attributes. Dotted ellipse is the symbol for derived attributes. Next attribute is multivalued attribute. Multivalued, in the name only it is there. It takes more number of values. Many values are possible to accept in a single attribute. Many number of values. It can have more than one value. Any attribute contains more than one value at a time. That is called as multivalued attribute. So which symbol is used for representing multivalued attribute means double ellipse. Many ellipses. Single ellipse for single value attribute. Two ellipses are used for multivalued attribute. For example, skills. Any person can have more than one skill. Some students or some persons are interested in painting, dancing, music, etc. So one person can have any number of skills. So that is called as multivalued attribute. So how can you draw multivalued attribute means write 2 takes 2 ellipses. Inside the ellipse you just write skills. Now I will give one example. Previously I took some example like student entity set with attributes, serial number, S name, age, marks, attribute and skills. Now take this example and I am drawing now ER diagram for this. So first student is an entity set. For entity set the symbol is rectangle. So take one rectangle. Inside the rectangle write the name of the entity set, name student. In this first field serial number is a single valued attribute. Single valued attribute means one simple ellipse is enough. Next one is S-name. S-name is a composite attribute because it takes more values. So composite attribute means first it is an attribute and parts of that S-name. That is first name, middle name, last name. So those everything kept in the above that S-name. Okay, so this is composite attribute. How many parts is possible to write it inside? Next, age. Age is a derived attribute. Derived attribute symbol is dotted ellipse. Next one is, next attribute is address. Address is also a composite attribute because also it is possible to divide it into so many parts like door number, street, city, etc. So this is a composite attribute representation because address is a composite attribute. And next one is skills. Skills is a multi-valued because any student can have more number of skills. Skills, how we write it means double ellipse. So this is a skills diagram. Student entity set, serial number is simply attributes, S name is composite attribute, age is a derived attribute, skills is the multi-valued attribute, address is the composite attribute. So this is the concept of what is an attribute, different types of attributes. The types of relationships. In ER model, one component is relationship. So now explain what is relationship and what are the different types of relationship in ER model. So what is a relationship means it's the association between entity set. So for relationship you are using one diagram that is rhombus. Rhombus symbol is used for representing relationship in ER model. The association between entity sets is known as relationship. Association or relation between entity sets is known as relationship. In ER model, R means relationship. So how many relationships we have? What are the types of relationships? There are 4 different types of relationships we have. Those are, number 1 is unary relationship. Second one is binary relationship. Third one is ternary relationship. Fourth one is n-array relationship. Unary means 1, binary 2, ternary 3. More than 3 is known as any number, that is n-array relationship. So these are the types of relationships. Now we'll explain each and every one step by step. Unary relationship. Unary means 1, single. That means in this relationship, the association between with only one entity set. The association with only one entity set is known as unary relationship. That means in this relationship, you are participated only one entity set, single entity set. You are maintaining relation with only one single entity is known as unary relationship. Here, strong, this is the entity set. In the previous video already explained, rectangle box is for entity set and your diamond box is rhombus is for relationship. So here only one entity set is the relationship within only one entity set. It is unary. Example, person is an entity set. What is the relationship means? Married. So one person is married another person. So here how many entity sets are there? Only person entity set. One person is married another person only. So that is called as unary relationship. Second one is binary relationship. Second category of relationships is binary relationship. Binary means 2. We know binary means 2. So in this relationship, how many entity sets are participated means 2 entity sets are participated. So the association or relation with 2 entity sets is known as binary relationship. Association between 2 entity sets is known as binary relationship. So here one entity set, one more entity set. These 2 entity sets are related with one relationship. This is the rhombus is for relationship diagram. So this is the representation of binary relationship. 2 entity sets, one relationship. For example, Employee is the one entity set. Employee. Company, where he works. Company is another entity set. So employee is one entity set. Company is another entity set. So employee works in particular company. So works is the relationship. So what is the relationship between employee and company? Means employee works in particular company. Second example, student is one entity set. College in another entity set. So the relationship between these two means student studies in that particular college. So the relationship is studies. So this is the binary relationship example. Two entity sets are related with one relationship. Employee works in company, students are studies in particular college. Third relationship is ternary relationship. Ternary means three. That means in this relationship, three entity sets are participated. Three entity sets are participated in this relationship, that is called as ternary relationship. How to draw this relationship means, take any three entity sets. This is the entity set, rectangle box. Second entity set and third entity set. These three entity sets are connected with one relation. The relation diagram is rhombus. So this is the relationship diagram. All three entity sets are connected with this relation. So this is called as ternary relationship. Example, student. Student is the first entity set. That means this is the information about all the students. Second one is, this is the extra courses. Student is learn some extra courses outside the college. So extra courses is another entity set, and he is studying some particular class. So class is the one entity set. So all these things three are related with one example relationship, studies. So student studies particular class and student studies extra courses. So in this relationship, three entity sets are involved. Last relationship is n-array relationship. What is n means? Here n is any number other than 3, because 1 means one entity set means unary, 2 means binary, 3 means ternary. Other than 3, anything, any number, that is called as n-array relationship. Relationship that contains that association with more than 3 entity sets is known as n-array relationship. N number of elements. N is any number. So more than 3, because up to 3 have some names are there, proper names are there. So more than 3, any value, that is called as n-array relationship. So diagrammatic representation is, I will take here 4, n equal to 4. So first entity set, this is the relationship. Second entity set, third entity set, then 4 entity sets. So in this example, I took 4 entity sets with one relationship. So this is called as n equal to 4. This is also known as quaternary relationship also. Quaternary relationship, because quarter means 4. Quaternary relationship means in this relationship it participated 4 entity sets. Now I will give some examples. Student entity set, that means it is the information about all the students. Second entity set is previous example only, like extra courses, who's learned some extra courses other than the class subjects, and he's learned some extra activities also, like basketball, music, singing, extra activities, not only studies, and his studies is regular classwork. So student, what is the relationship? All these things means studies. Student studies is regular classwork, student studies extra courses, student learns some extra activities. So in this relationship, there are 4 entity sets are there. All 4 entity sets are related with one relationship. So this is the relationships, types of relationships. What is the relationship? Types of relationships. So what is the 3-level architecture? So this is the diagram for 3-level architecture. So first we'll go for what is the 3 levels. What are the names of the 3 levels? Means first level is physical level architecture or physical schema. Second one is logical level, logical schema. Third one is view level, view schema. So physical level is also known as internal level. Logical level is also known as conceptual level. View level is known as external level. So this is the names for 3 level architecture. So here this is the diagram. First database. Database means as a collection of data, and here users are there. Users are using this database depending upon their requirement. That's why external view is number of view. This is also called as view level also. So these users are using the database. But this entire database, for protecting your entire database, that's why we are requiring 3 levels. So users are using the database, but they don't know how it is stored, where it is stored. Just they are using the database only. That's why it is protecting the database. They abstract the database, but total implementation is hide from the users. So this is the 3 level of architecture. So before going the 3 level architecture, first we know what is the schema. Schema. What is schema? Means it is a structure of database, skeleton of the database, how the data is stored, in which format the data is stored. That is, entire thing is explained using schema. For example, I have database like 1A and 18. So this is the data. So what 1 indicates? 1 indicates the serial number, A indicates name of the student, 18 indicates student age. So if the data is stored in this format, that is called as schema. What is the name of the table? We need one name for the table. So the table name is student. Student is the name of the table. So what are the fields are there? Serial number, yes name, age. So these are the fields. That means 1 is stored in serial number, A is stored in student name, 18 is stored in age. So this is the structure of the student. So what is the syntax? Means table name, field 1, field 2, so on. How many fields you want? Keep all the fields in this. So this is the structure of this table, and also it explains what are the primary key, what is the relation between one field to another field. Everything is explained. That is known as schema. So after that there are 3 schema architecture is there. That is also called as 3 level architecture. The main purpose of this architecture is protecting your database. Hide from the users only implementation. So one is the physical level or physical schema, logical level or logical schema or conceptual schema. Third one is view level, view schema or external schema. Okay, in this physical level, it totally concentrate on how the database is stored, how the data is stored, where the data is stored. It describes the physical storage structure of the data. It is mostly concentrate on storage devices only, where it is stored, all about the storage areas. Physical data is totally concentrate on the storage devices only, where it is stored. It describes the physical storage structure, everything physically. Second one is logical level. This logical level is also known as conceptual level. In this, it explains the structure of the whole database. What is the structure of the database? What are the fields are there? What are the entities are there? What is the data types? What is the relationship between one entity to another entity, or relationship between field to field? Any constraints are there? Key constraints, primary key constraints, everything is explained in the conceptual level. So in the conceptual level, what type of data we are stored. Next, in view level. View level is also known as users level, external level. Depends upon the user's requirements. They will see the information. That's why view levels are more. So in the physical level, we concentrate on how the data is stored, where the data is stored. In logical level, what type of data is stored. So this is everything is known as 3 level architecture. 3 level architecture depends upon this. We go for physical data, in data independence also. The main concept of this tree-level architecture is data independence. Thank you for watching my video. If you like this video, subscribe my channel, like it, share it. Thank you.